What I'm going to do now is ask the presenters to put the videos on, and we'll go into the panel session. We have had a couple of questions posed, but by all means, any of the delegates use the Q&A window to pose additional questions. Let me start with one of the last questions posed, which was, Christina, you mentioned new engineering skills, and I guess that's applicable to all the areas. What sort of things are we looking at? Christina, do you want to pick up on that?
Yes, so especially in engine controls, we are used to just use MATLAB Simulink and normal programming for these engine control units. And here our technical field is not yet very used to these neural networks and to AI algorithms for really the engine control, like throttle valves and so on. So there, for at least in AVL, we need to build up more knowledge about these topics.
And Cyprian, from a Infineon's viewpoint, do you find changes in the needs of your customers in terms of moving from engineers to people who perhaps more IT related?
Generally, this move is observable, yeah. While I think it differentiates quite a lot across the different business lines. For example, if you look at automotive, this is, from my perception, a slower moving business in this sense. The whole value chain is quite established, and I think the people sense, and it also happens already, that changes need to happen, but it's rather slower than I observed it in my former employment, which was with mobile systems, means mobile systems of handsets, which has a much higher dynamic. Yeah? But in general, this trend has to be coped with, and I definitely see the need that this is moving forward. As I said, in automotive, I would say the customers are rather not yet asking so explicitly for the expertise. Yeah.
Okay, and Prof. Crossu, obviously your talk started with very much biologically inspired systems, something that engineers wouldn't necessarily come across. How do you see our ability to include some of these wider experiences?
Let's point out first that actually neural networks were originally inspired by biology too. It's only that the idea was that they were inspired by spiking neurons because most of our neurons are spiking. The only problem with this is that the activation functions used in deep neural networks nowadays, they are not spiking. Okay, so they are really smooth. And this model that was originally developed for artificial neural networks for a single neuron is not correct from a biophysical point of view. Now, when you connect the neurons together, you get to a model that is closer to, let's say, a biological model, but it's still a conductance model. I mean, like I showed, actually what happens is that you have currents passing through the membrane of a neuron. Now, I think every electrical engineer would be able to understand a capacitor model. I think almost every participant here has looked once in his life at a capacitor equation. So this actually builds a link between, let's say, deep neural networks, which are in fact analog, and this biological model that I've shown. Now, they are very similar with the single difference that we have an additional gating component, which makes currents out of, so it's not, the rate of change of the membrane potential is not the sum of conductances, it's the sum of currents, like we all know from physics and from electrical engineering. So, but it has advantages in terms of what it can express. So what you learn with them, and we use the same tools as everybody else. We use TensorFlow, Keras TensorFlow. So we can apply exactly the same tools to do machine learning. The only difference is that our resulting networks are much smaller and much more robust to noise, because the capacitor itself, if you remember from electrical engineering, is a filter. It's a low-pass filter and high-pass filter, depending how you set it up. So it automatically filters noise, similarly like what happens in our brain. So I think that in this respect, I don't think there is a problem from engineers to get into AI, because they're going to see their equations that they were accustomed to. And I think that we are now seeing a convergence also between control theory and machine learning, because much of what we are doing with reinforcement learning, this was called optimal control before. Supervised learning is called system identification in engineering. And so I think that there is a very nice convergence that takes place that is happening now. And we have to teach the students these things and let them work with the tools from machine learning. And I think we are on a good path for the future.
Thank you. And Garion, are you seeing a wider community being used to prepare the roadmaps that now we're not only using engineers with a high degree of knowledge of car and automotive systems, but now requiring the skills from ICT people who really understand the AI components, but don't understand what a car does?
It's exactly this. I think the nice thing about the partnerships that are being prepared for Horizon Europe is that they're quite strategic, and strategic in the sense of combining technical knowledge with non-technical knowledge, with user expectations and so on. And all of a sudden, this can no longer be served by just bringing in your engineering knowledge out of a small segment of the technology spectrum, but you need comprehensive solutions from the start then. Just consider those examples as we have seen them in the presentations, or that I tried to show, with humans and machines interacting. And I believe it's very clear that therefore, that part of knowledge needs to be included, and it's really difficult to distinguish the importance and the roles of just little breaks out of that.
Okay. And Elizabeth, just a comment from you about membership of EPoSS. Are you seeing more ICT companies or different companies joining EPoSS compared to the traditional membership?
Sorry, I was muted. Actually, we are working on that, and this is also the idea with initiating these kind of webinars and working together, because our board has identified how important AI at the edge is for the EPoSS community, and so they told me to really move in this direction. And of course, we are welcoming people bringing in these opportunities. We have, as you've seen around the table, Infineon, AVL, being members of EPoSS since long time and being already part of this. But I think it is an area, a growing area of interest for our members, and an area where we should connect also with companies not yet being members. So warm welcome to everybody who is interested in this kind of collaboration.
Thank you. And Simon, within the KTN, do you think we're seeing more cross-sector work than we had traditionally done within individual sectors?
Yeah, I think there's a definite drive towards it, because people are starting to struggle inside their own fields, especially having worked with the transport team at KTN on things like the connected autonomous vehicle work with embedded systems. It feels like people are having to bring multi-talented teams together to cover different aspects, most definitely.
Thank you. How, obviously you're building a new company and coming from an ICT background potentially. Do you find that you have to include engineers that understand car systems, or because of the areas you work, it is primarily software type skills and AI?
That's a really interesting question, actually. So I think from our team, the main expertise is in computer vision, image processing, deep learning. Some of our team come from medical image processing background, or from a pure maybe robotic or deep learning. So so it's really, I think our team's expertise is really on the AI side. So there's definitely learning in terms of the automotive transportation market, learning about the pain points, etc. Where I find working with partners and collaborators really, really helpful for that aspect. So I think from our team is really coming from a technical perspective. How do we address some of the technical solutions, and sort of acquiring other skills as well? So it's really a mix. But it's definitely quite interesting. So that's why when we are onboarding new members, usually we would give them a task that's looking at processing some automotive related data. But a lot of them haven't come from that background, but was able to, with the background information, to deliver what we need technically. And there's usually, we would have a lot of sessions on looking at industry development, etc. So acquiring the industry insight through our own research, but I think most importantly through collaboration with partners and customers in this field. Okay,
and Alfred, I'm going to continue with you, because we've seen within the context of a car, we see that the power requirements for the AI systems, the GPUs, etc., are quite significant. Maybe new technologies are helping develop it down. But when we come on to other areas such as drones, can you ever conceive some of these systems being power efficient enough to put within a drone?
Yeah, absolutely. So it's some of them. Sorry, I'll let you finish this.
No, it's going. Yeah, how hard are we pushing the power budgets these days? Is it going to require something really dramatic to get low power?
I think with a drone application, with the payload and with the battery capacity, I think power is even more important there as well for, say, autonomous operation. While we primarily focus on automotive and transportation, I think one of the key things is, can we add more functionalities to some of our customers, their existing computing platform, especially when they already have a system, say buses or in a public transport space. I think that's where that would really make a big difference in that sense, because it's a difference between AI and no AI at all using the same system, and it can really for them to add a lot of value. So I think that's kind of where we focus on as well. It's to enable application that wouldn't have been possible if it wasn't for algorithm that's able to run on extremely power efficient computing platforms.
Okay. And Cyprian, you obviously focused on both the power budget and the data budgets that come in from these. Do you ever look at very low power stuff, the sort of things that would be applicable to drone type systems?
Yeah, to a certain extent, especially the project which I showed has the target to find solutions to this, and I think, as I showed also in the presentation, it is crucial to find solutions here which enable us to cope with these complexities which we are facing, because it's not effectively, it's not a solution to run with 1 kilowatt compute power in the trunk when you want to reach a certain range with your electric car, yeah, at the end. And here I would say, at least to the experience which we gained so far through the project, I would see a little bit different with the skills which you need, by the way, for addressing these topics. Talking about spiking neural networks, here the coding of the information is already a challenge in itself. So if we start doing a processing in an asynchronous and analog fashion with these networks, we have to deal with completely different codes and encodings as we would do with these classical artificial neural networks. Yeah? It's not a vector matrix operation. It's temporal contrast encodings and stuff like that, which you have to look at. And sometimes it's really taking a completely different viewpoint to the problems. And I think this is a skill which need to be substantially developed. This is something which is not that present, and also you find rarely in the education, because these networks were primarily driven through the biological motivation and mimic the biological behavior, explaining it. But when we're now looking at the industrial usage, it's all about these encodings, the learning algorithms for it, and they are quite different to the classical artificial neural networks as we know it. Yeah.
Okay, and obviously, Radu, your presentation was showing ways of doing quite dramatic reduction in power. Do you think that will continue with ever more power efficient systems?
Yeah, absolutely. I think the key to understanding what we are doing relies in having expressive solutions that lead to very small networks that are easily explainable. Now, let me point out that in my view, this analog computation that I showed, you can think of it as the part of machine learning, and you can think of it as the firing rate of spiking neurons. So if you want to put this in a low power system, you have to implement everything with spiking neurons. I mean, there is no other way. But my view is that spikes are really an efficient analog to digital conversion. You convert the amplitude of a signal to a spike train, which is easy to reinforce. It's pretty much like digital transmission. Neurons do this at the beginning of the axon, and at the end of the axon, they convert it back to concentration of neurotransmitters. So from the point of view of learning, what the neurons see is really something that is totally analog. But you cannot reliably transmit the information from A to B if you don't do spiking. So that's where the advantage, I mean, no matter what implementation of machine learning you want to do that is power efficient, like our brain, for example, which is amazingly power efficient, you have to do this analog to digital conversion. So these two things, you can decouple the learning component from the implementation part. You know, from the point of view of learning, it's enough for you to know that you have a spiking rate, and that gives you an amplitude, and there you can do the machine learning. But if you want to run this efficiently, we have to develop this, and I'm very happy that Infineon is doing this, you know, because this is, even in chips, you cannot reliably transmit information of even on small distances because of noise. So you have to do spiking. I mean, that's why the life found out that they need to have spiking neurons if you have to propagate on large distances. Now in the retina, which is only 0.5 millimeter thick, the neurons are not spiking, and there are billions of them. You know, everything in the retina, which is has 6 layers of neurons, happens in analog. But that information to be transmitted to the brain, you know, to further processing, is done with spikes. So these two things coexist actually.
It's interesting because we had thought we may do a webinar on really advanced implementations, looking at in-memory processing, all sorts of things, as part of the AI, trying to predict what will happen in 10, 15 years. Gary, and just broadening it out, obviously today we have done a focus on connected autonomous vehicles. Are we missing other applications for AI within the car? That what we're looking at is the sexy new stuff of being able to go to work whilst reading a book in the back seat, but in fact the autonomous systems and the AI, as Christina demonstrated, in things like fuel economy, engine control, the driver sort of safety systems, is that an area that we should have focused on, and is that an area where you see great developments?
Actually, I think it's both. Of course, in the first place, it's applications in automation connectivity seem to be a little bit more sexy, right? So it's like, as you're saying, you immediately can imagine situations where you sit in the back of the car and you're playing things and you're reading a book or whatever instead of driving, whereas the applications in the powertrain you probably will not see. Yeah. But on the other hand, I think it's a very exciting application field too. It's probably something that's a bit less driven by customer demand rather than by regulation, for example. Just consider that we all need to justify in Europe our actions, activities, our proposals for topics against a Green Deal. And if we want to do that, we absolutely have to consider these as well. And I believe that there's still far more, but of course, powertrain and control is the most obvious ones. But if you go beyond that and leave the car and just consider, all the situations we are in a mobility system, how, for example, streams of people and paths of people are maybe controlled and steered and proposed, anticipated in a city. There's a huge area where it could play an important role too.
Okay. And one question, Christina, do you have a comment in that you're working down in the actual systems within a car? Do you ever feel you'd love to do more on the self-driving vehicles?
On the self-driving vehicles, we at AVL, we also trying to get a foot in, and but also for just for the powertrain controls itself. The application of AI is relatively recently employed in our company due to the gained experience that on the neural networks and on the AI technologies. And it is very likely that we discover new areas for improvement on that also in the powertrain control.
That just a personal comment. That's very interesting. Within the UK, we've got a big program on electric drivetrains. Well, really power electronics, where it has been around motors, it's been around the power electronic side. But one of the things that is becoming clear is that the controls in those areas are much less known. So I may come back and ask you to talk on something else. A final question that we probably can't miss out, which is ethics and predictability on AI. Let's start with Gerin. Do you see that that is going to be the real stumbling block for self-driving vehicles? Do you hit a child or a Belisha beat?
I believe I understand the point. This has to do a lot with awareness, right? So people, of course, need to understand how an AI system would react and would decide compared to a classical system, in order to better get and maybe better accept something that might otherwise be a little bit unsure or maybe frightening. The important thing that also engineers need to understand is that an AI system is a system that needs to be trained, and that of course needs to be tested in order to understand how it will react. And that's a complete change of paradigm. And it's also something that, again, in the technical community, people need to be a little bit more aware of at first, and then it is something that also users need to understand and need to be made aware of, that maybe the technical system might be behaving like a person that's learning something from scratch.
And Cyprian, a difficult question, I'm sure. Where does responsibility lie? With the supplier of the technology, the person who programs it, or the person who sells the vehicle, or the driver?
As of today, with the ADAS systems, I lost your audio.
Sorry, I spoke. It is, just how do you control who has responsibility in these areas?
One short answer would be not at all. But the point is that the reason is for ADAS systems, there's the clear definition that the driver still is in charge up to level 3, and level 4 and 5 are the ones which are getting autonomous. And here we have to find also different models. I would say in the first place, it's definitely a kind of not yet really fully clarified setup, who's responsible and who takes responsible. I would give here just my very individual view on this, and I would say what we mostly have to work on is and have to hardly work on, I think, is this perception of how these solutions are, the perception of these solutions is. Because if you imagine there's an autonomous driving vehicle which is causing a deadly accident, and then compare it to a human driver, and if we look then at the statistics, let's say you have deployed autonomous driving in a large scale, and you can prove that the amount of deadly accidents is 10% of that what we had beforehand, with human drivers. Nevertheless, I think there will be a huge debate about that. With this autonomous car, or a vehicle which was causing these deadly accidents. As I said, from a kind of individual viewpoint onto this, in the first place, a lot of that should be actually covered by a reasonable setup with the insurance settings, because there's certainly an ethic discussion, but if you can prove that you come down with to 10% of the former accidents, from a certain point of view, it doesn't matter who is causing the accident, you have less, and it's actually an improvement, but it's quite obvious that there still will be the discussion about the moral component of this, because it's a machine and not a human which was causing that, but if you take a very let's say fact-based or statistic-based view onto this, actually it should be, as long as it is sufficiently well addressed by concepts for the insurance, being addressed. But as I said, I think this is one thing which is still to be discussed in great detail, and we are not yet there.
Thank you very much. It was a difficult question. We're at time, but I was going to just ask one last question to each of the presenters, which is about the future, the bits we accept, we don't know. Where do you think we'll be in 10 years' time? And is there anything that would really surprise us? Radu, start with you. Where will we be in 10 years?
Yeah, I think we are going to see these spiking neurons. I mean, control is going to merge. Control theory, computer science, and machine learning, artificial intelligence are going to join forces. It's more or less the same field. I very much hope that people were shy before to get into nonlinear controllers. So that was the big difference in control theory. People were identifying linear systems. Now we go in nonlinear systems. So my hope is that the systems that we are going to synthesize in the future are going to be understandable, much more understandable, partially, if you like, maybe designed, and only what is not totally unknown is going to be learned, but what is known should be out there. Like in convolutional neural networks, there is an architecture, and that's why they are so, which was inspired by biology, the receptive fields. So I think we are going to have much more explainable models. We are going to have huge data sets which are going to be able to solve some problems in ethics, because we are going to ask our machines to do exactly what the people do, and if we give them training data, they can learn that, and we are not going to be surprised what these machines are going to do. And yeah, it's going to be a lot of automation. Our systems, it's going to take still a long time to get to the amazing abilities of the real neurons. So we are still going to be the smarter ones. So there is still hope for us.
Thank you. How do you see 10 years' time?
I think Radu covers it really well, like in a very comprehensive way. I think what I would hope to see is also the the use case and the application of computer vision deep learning becoming even more prevalent than today, and further contributing to autonomous systems, and also an increase in terms of the human trust in those systems, how we work together alongside with them, and really allowing them to contribute to productivity, efficiency, and well-beings of human beings. So that's really what I hope to see, and what we wish to see too.
And Christina, how do you see your world in 10 years?
Yeah, hopefully AI on the edge will be an essential part of the safety critical components also in engine controls, and will help us to to keep the emission legislation limits, to keep them and to get the world a little bit nicer.
Thank you. And Cyprian.
Yeah, a lot was said already. I want to just comment a little bit more pessimistic, because usually one tends to have a colorful picture of the future. And this is based on my history, because I was first in contact in the 2000s, early 2000s, with spiking neural networks, doing simulations on that, and seeing now after 20 years what's happened and or not happened. So, but anyway, I also hope to see that we have parts of this as a solution in autonomous driving cars in 10 years. Yeah, there are companies out there which are claiming that we are earlier with autonomous driving. I guess we can be lucky to see it in 10 years.
And Garion, coming to you, I'm afraid I came to you last on the grounds that you do lots of work on roadmaps, and therefore you know what we're doing in 10 years' time. How would you see it?
Sure, I won't tell you. No, Nigel, I believe, I still believe that mobility is an area where, as I said, people are experts, everybody can tell about it. And therefore it's so prominent on the agendas. But at the same time, we do see a lot of potential of transfer into other application fields. And I think that's the big opportunity that we have, and that we see applications in health, or that we see applications in city development and so on. And I'm a bit more optimistic. Maybe I have the hope that it will make technology in everyday life a little bit more wise. And so I'm thinking of maybe we turn smart mobility and smart cities into wise mobility and wise cities, and that definitely needs a lot of AI.
Well, it's always nice to end a webinar on a positive note. So with that, I would like to bring this session to a close. We will issue a feedback form. Please do fill that in and just give us some comments. There is the Meeting Mojo sessions running all this afternoon. So if you want to connect to other people, please do go on there and find out who the other delegates are. And I'd encourage you all to try and connect. So our next webinar will be in early December. I have in fact got 1 or 2 slots still open. So if anyone is actually working on AI implementations in healthcare, particularly interested in instrumentation there, so bringing it down towards how medical instruments are improving with embedded AI. But thank you very much to all the speakers and the organizers. It has been a pleasure working with you all for this time. And thank you very much for those delegates that are still with us. I hope you've enjoyed it. Use the feedback form to tell us how excellent it was, which is the preferable answer, or what we need to improve. Thank you very much, everyone. I'll now ask Natasha to close the session.